Hello guys, welcome to my YouTube channel. So today I am going to explain you one of the most important and most useful concept which is called autoscaling. So today we will see how we can perform the autoscaling, and also we can perform what the type of autoscaling do we have in Kubernetes. So first of all, we have horizontal autoscaling, and we also have the cluster autoscaling. So yes, so if you see that, like, in terms of horizontal autoscaling, I am just mentioning here autoscaling. So we also have the vertical autoscaling. So but we will see how vertical autoscaling works and why we are not taking much importance for the vertical autoscaling. So I'm just mentioning here all the things. So you can see that I have the three autoscaling, right? So in a horizontal autoscaling, we actually works with the help with pods. So I'm mentioning here pods, and in the cluster autoscaling, we work the repeating unit of the clustering autoscaling is the nodes. So what happened in the horizontal and cluster autoscaling? In the horizontal autoscaling, when the request or request data increases, or the request all coming to the cluster or coming to the our microservice will increases, our actually our Kubernetes kubelets will automatically detect that and will start creating the more pods to, like, balance the traffic between all. So load balancer is automatically connected, already connected to that the pod to the pod or to the deployment, and our kubelet will automatically create the pod inside our Kubernetes or inside your node or inside your Kubernetes cluster. So that's autoscaling, which is called the horizontal autoscaling. And cluster level autoscaling is something like when actually when we are just increasing the cluster, increasing the nodes inside the cluster. That's autoscaling, which is called the cluster autoscaling. So vertical autoscaling, which is like we are doing or autoscaling our pods or increase their or adding their memory and the CPU power dynamically to any pod. But this autoscaling not working most of the times, or most of the time it is a very critical environment for the vertical autoscaling. So most of the time it's like a not a, in future maybe this concept will come into the picture, but right now it's not in use actually. So people are not using this vertical autoscaling. So we only have right now the two autoscaling. So I will explain you how we can, with the help of demo, how you can do that. But before that, I hope this concept is clear for you: horizontal autoscaling and vertical cluster level autoscaling. So now, how like the clustering autoscaling works in terms of the load is increases. If the load is increases, load balancer is connected to that, to our clustering autoscaling. So load balancer will detect that load and automatically increase their number of nodes. And in horizontal autoscaling as well, load balancer will detect that and will increase our load. So I will show you like demo how we can do that. So here actually I am using the EKS cluster. So for that I am using the node group. Inside the node group you have to just mention some settings, and with the help of that setting you can do the cluster level autoscaling. So here I have three settings which is included, like scaling config. I have desired size of nodes, maximum node, how much node can I launch, and minimum size of node. So here is some settings you need to put when you are doing the node level autoscaling. Everything is managed automatically by the EKS, so you no need to worry on that. If you managing things via your personal, or you have the some actually Kubernetes environment which is a standalone service you are running, so at that time you have to take care, or you have to launch the servers and doing the automation, something like that there. But right now I'm using the EKS, so AWS will handle everything. So this is the example of the node level autoscaling. So now I will give you the example of pod level autoscaling. So in the for the horizontal pod level autoscaling, we have the one resource which is called horizontal pod autoscaler. So this resources is very important. So inside this resources, I will just explain this what this resources is. So here I am just putting the name, scale and scale target reference. It's something like deployment, which means that when the loads comes, if you want to auto scale, you can go via the deployment. So inside that you can see here I am putting here minimum replicas 1, means at the time of minimum load you should create the 1 deployment, and at the maximum load you create scale your deployment up to the 5. We can put any number here. Now we have the matrices and the resources. We can have CPU utilization, and here is the one thing is that average utilization. If my average utilization go beyond that, means my average utilization in that case, if it's a 10, and if my average utilization go to the 11, then this will automatically scale my new pod or new deployment and like load balance or balance all the traffic between these two deployments. If then our average utilization go to the beyond 10, then it's again create the next deployment. So here is the observe generations and all the attributes. Current replicas we can say 1, desired replicas how much we can auto scale, maximum replica here, but desired replicas in the first case how much should I put. So I am mentioning here the 3. So we can here the current matrices like CPU and all. Here are the few flag which you can put based on your choice. So this is the one resource which really helpful for our deployment, our horizontal pod autoscale deployment. So that's for the demo part. So now I want to explain you one of the most important thing about the autoscaling is that in the horizontal pod autoscaling, when the load or traffic is increases, it's a one scenario you can consider in that way. Our traffic increases and our horizontal pod autoscaling is scaling my pods. So it's my scaling my pods and scaling my deployment or pods in my nodes, but it's up to the mark. But sometimes our node will say, okay, I am done with this pod, I can't like put one more pod in my structure because I am already full. So my Kubernetes will automatically detect that, and now the next pod will go to the pending state. So my Kubernetes already detect that and see that okay, so many pods are in the pending state, which means that my node is not like my node is full. So I need to create the new node, I need to schedule a new node. So my Kubernetes will schedule a new node and all pod will be launched inside that schedule or new node. So that's how the deployment works. When the traffic comes, it's first of all it will prioritize the horizontal autoscaling. It will scale down the pod, and once that node is full, all node is full in your cluster, then it will create the new node, because the pod are going to the pending state. So they need to take care of that pod should be in the runnable state, not a pending state. So that's how this overall autoscaling works in the Kubernetes environment. So our controller manager will detect that okay, my pod is going to the pending state, and it will ping scheduler that and saying that please schedule a new node. So scheduler will ping API servers and this will create the new node. So that's how like autoscaling work in the Kubernetes environment. So yeah, that's pretty much from my side. Thank you. If you like this video, please hit the like button. Thank you.